The next tool I want to show you is the Resource Monitor. I'm just going to click on the Start button and I'm going to start typing the word resource and it pops up in the list. You can also go to Administrative Tools and it's in Administrative Tools. But here, I'm just going to go ahead and click on Resource Monitor. And I'm going to put this in full screen. This Resource Monitor is very similar to Task Manager, but I find that it's much more informative. This covers the 4 subsystem components: CPU, memory, disk, network. This actually shows me every process on my computer that generates CPU activity. I'm actually going to go ahead and open Internet Explorer. Internet Explorer is now going to show up in the list, so I'm going to click that here. Whatever you select, you actually filter. So I'm going to scroll back to the top, and you'll see iExplore.exe, Internet Explorer. That's checked. So for that, I can view how many threads against the CPU that actually has. I can view the current CPU time, average CPU time since I clicked on it. If we kind of scroll down this page here, I can see that Internet Explorer has no services associated with it. If you select a process with a service, it actually shows up here. It'll give you the name of the process, the status, CPU and average CPU time for that specific process. It also shows me all the associated handles, which are basically connections that this application has within the CPU. If we scroll down this list, I can see it's connected to a few things in my app data store. If I keep scrolling, I can see it is connected to several registry keys. So this registry user, the registry machine, well, that would be the HKey local machine. So all of these registry keys, and there are many keys in that list. It's always more than I think it's going to be, but a lot of connections. Now, we would not call this a forensic analysis, but it's kind of teetering around the periphery of that. It lets me take a process, and I can see for that one process how that process interacts with everything at the CPU level, every connection that's actually made. Now, if we go to the Memory tab, the Memory tab, to me, not as interesting. When you look at the Memory tab, the only real takeaways here is how much memory you actually have, how much of that is in use versus how much is available. So I can see I have almost 3 gigs of RAM available, just over 5 gigs in use. This machine has 8 gigs of RAM total. Now the commit, working set, shareable, private, honestly, those are not of concern to us anymore. Not since the days of DOS have you been able to load an application into memory where you want it to actually run. So with this, there's nothing you can do about any of these numbers. So our only takeaway, really, if you have more applications that you want to load, you want to make sure you have the resources available to run those applications. Otherwise, you would need to run those apps on a different machine, or you would need to increase the amount of memory. Of all the things here, the one we would pay most attention to is hard faults per second. Now that could have been named so much better. But a hard fault per second is how many times something that's been loaded into memory has been moved to the page file. So the page file on your computer is a spot on the hard drive that acts like memory. We call it virtual memory. When I open all these processes on my computer, eventually you would actually fill up memory completely and you would not be able to run a new application. So what your computer does, it takes some of the things out of memory that you're currently not using, and it actually saves those to the hard drive to this location called the pagefile.sys. So that process is known as virtual memory, is the overarching term for that process. The concern with that, if I only have 1 gig of RAM in my server, which is actually the minimum, if I have 1 gig of RAM and I try to run several applications, I physically do not have enough memory to run all these applications, So my computer is going to move a lot more content to the hard drive. If a computer, same make, same model, but it has 16 gigs of RAM compared to the 1 gig of RAM, it now has a surplus of memory. So it can store many more things in memory, and it has to move far less content to the hard drive, which means it's actually faster. Now, what I compare that to in non-technical terms, if I have an apartment that is 500 square feet, then I win the lottery, and I buy a house that's 5,000 square feet. Well, to compare the two, if I have a 500 square foot apartment, I don't have a lot of room. So a lot of my belongings would have to reside in storage because I physically don't have enough room to put everything I own in a 500 square foot apartment. We win the lottery. Now you go buy a massive house, 5,000 square feet. Well, now you have a surplus of space. You have to put very few things, if any, in storage because everything now fits in this bigger house. That's a non-technical way I think of having more memory in a computer. You physically have more space to store all this stuff, so it spends less time actually writing, or paging is a term that's common used, spends less time paging to that page file on the hard drive. So this hard faults per second, you want this to ideally be all zeros. When a number shows up here, it means something had to be retrieved from the page file, loaded into memory, and something else was swapped into that page file. If you don't have a lot of memory, you'll notice you just frequently have numbers other than zero here. So that is an important column. Equally important is the disk column. Now notice Internet Explorer is not in this list. If I deselect image, notice that only a few things show up. System, perfmon, and this MSMP engine. Internet Explorer is no longer in the list. The reason is because the activity subsided. Internet Explorer is not generating any disk activity, so it's not actually in the list. What I'm going to do is pull up Internet Explorer again. Now, it's still open, but it just kind of went quiet. I'm just going to click on one of my links here. Well, I'm going to click on this PowerShell link. That generated a bit of activity. So notice now Internet Explorer is in the list. And actually, I have two of those showing up. Now, I have multiple tabs in Internet Explorer, so you'll often see multiple sessions actually show up in Internet Explorer. With this, I can see how much is read and written in bytes per second. If I expand disk activity, I can also see that Internet Explorer is reading or writing to these locations. So I can see DLL files, I can see the master file table, log files, and it shows me for each of those locations how much is read and written. Under the storage, it shows me the disk queue length. Now, ideally, we want a disk queue length to be 000. If you have a slower hard drive, like a 5400 RPM hard drive, when you start opening a bunch of programs, your hard drive physically cannot keep up with the demands you're placing on it because it's a slower spinning hard drive. So what happens, everything sits in a queue and you have to wait for it to be processed down. So that just in turn slows the entire computer down.